You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello, listeners. Welcome back to the Interactome. And today we have a really exciting topic in which we're going to talk about building labs. So, listeners, I will first pose you a question. When somebody says science lab, what image pops into your mind? And what does it look like? I'm Maya. I'll be helping to host today's episode about building labs. And first, I'll turn that question, what do you think a science lab looks like, back to our other hosts that are here with us today. So, Sam and Joe, before you guys started to work in a lab, what did you think they looked like?
Honestly, I kind of just pictured this, like, mysterious, white, pristine, perfectly clean facility where people in white coats would, like, walk around in dim lighting and never talk to each other. That's kind of what I pictured when I thought of science lab. Now that I have been in a lab for a little while, I think that's in terms of in some cases that's true, like certain kind of clean rooms where you literally can't have anything like contaminating what you're working with. But in general, the lighting is a lot nicer. Oftentimes we have nice windows out into the open rest of the world, which is nice. I always thought labs were like kind of dark, mysterious places underground. But yeah, it just, in general, the labs that I have had the privilege to work in are generally very open and spacious with a lot of little bench tops, generally black, hard bench tops where you can put a lot of different kinds of things. You can spill a lot of compounds or chemicals or bacteria or whatever, and it's all okay. You can just clean it up, and it won't damage the counter. There's usually a lot of sinks where you can kind of like clean your glassware, your different flasks and whatnot. And there's usually some incubators and things like that too. So that's kind of what I picture now.
What about you, Sam?
So I don't really remember what I thought of labs before I had been in one. I guess like my first impressions of labs were always like the labs in like high school and stuff, but I always knew that those were kind of like not real labs. So like the classroom labs. Actually, I think there was like first time I'd ever done like a science lab was in like elementary school, like Dissected Squid or something. There's like one weird science lab room somewhere. I guess that was the first time I'd ever like set foot in like a proper science lab. But I actually think I saw a clean room before that, weirdly enough. I don't remember exactly why. I guess my dad had a friend with a clean room, so I'd seen that. But I guess when I thought of like...
As friends do.
Well, he owned like a microprocessor fab or something, this guy did.
Cool.
But I think really, if I were to jump to like what my immediate picture of a lab was, I'd probably think of like the lab in Jurassic Park. That feels like kind of the image in my head, which I don't think really looks much like a real lab. There's a lot more computers. I guess it's probably more of like a computational thing. But nowadays, pretty much what Joe said is what I picture with a normal, like a real lab. It's just a lot of like benches and usually a lot of random stuff lying around, depending on what the lab is. Scientists are really bad at getting rid of old stuff. So there's usually something in the room that nobody knows what it does, but nobody wants to get rid of it. And the reason we're talking about this is not because we are experts on labs, although we're experts on sitting in them or working in them, but because we actually have an old friend here who designs labs. So we have with us today Ewan Ellis, who works as an architect who designs lab. So if you want to introduce yourself and kind of kick us off with the real details of everything.
Hi, so I am Ewan Ellis. I work as a designer at a property management company, and I specialize in designing laboratories.
So what is it like building a lab? So like what is the kind of the process of building a lab? Because I think for all of us who work in labs, we just kind of accept that they're either things that magically come into existence somehow, or we are subjected to the noise of making a lab all the time, like I have been recently. But I'm still not entirely sure what's going on or how the process actually works. So, do you have any kind of ways of laying out how that works? Or
Yeah, I mean, I would describe it a bit like a puzzle, or maybe what I would say, I would call it, imagine you have to build a Jenga tower, but in the order you took it apart. So you're kind of building pieces and making sure they fit together without the whole thing falling down. Because yeah, it's a lot of like things have to fit together properly. I've been amazed as time has gone on that yeah, you have to make sure every little piece can fit properly, and there's all these like constraints that you don't always think about. So yeah, it's like a puzzle, like one of those. Have you ever seen those 3D puzzles?
yeah,
Oh yeah.
Or like the ones you get at like in like Christmas crackers.
Mm.
It's like those.
So what kind of pieces go into the puzzle, Ewan?
So I mean, we're talking about electrical, plumbing, HVAC, which is like your air conditioning, your heating. In labs, there's a lot of specialty stuff. So plumbing can include all of your gases, so like nitrogen, carbon dioxide, compressed air, all that sort of stuff. Yeah, it's crazy, and then it all depends on. For example, you have in the latest one I did, it was all open ceiling,
Ooh.
which really sounds easier, but it has its own challenges because when it's just a regular like drop ceiling like you see in office, you can just like jumble it up there and it doesn't have to look pretty. But with an open ceiling, it has to look pristine and beautiful and be as much a part of the lab as anything else. It's a lot tougher.
By open ceiling, do you mean that the ceilings are just really high?
Not always. This open ceiling was only about, I want to say it was like only 11 feet high.
Okay.
Which I don't know, like for like a frame of reference, like most of the labs we design, the ceiling will be at about 9 feet, 10 feet maybe. So not too much higher.
I was gonna say for open ceiling, you mean that like you're just saying that there's no drop ceiling or something, right? The next floor is right above it. There's not like a bunch of space to cram all the ugly stuff.
Oh yeah,
right?
it's just concrete. It's just bare concrete.
Oh, I see. I literally thought you meant like no ceiling. Just
yeah,
like
I was like,
hole
no roof.
where a roof would be.
No roof, just open to the elements.
Would that be easy to design, Ewan?
That would be impossible unless you're doing field work. It's not going to fly.
Yeah.
Speaking of things not flying, when you talk about the like design experience of designing a lab, it's not just the physical bits, right? Like I can imagine that there are other constraints besides making sure the physical Jenga pieces go together, right? There's a lot of other things that happen first, or even just like kind of rule what you're doing, right? It's not just literal nuts and bolts, right?
Yeah, I mean, what I could probably talk about is sort of how this process goes to get. Do you guys want me to talk about like how we start the whole process, or do you want me to like go like? Because I can talk about, say, for example, all of the permitting we have to go through, everything with the client that we have to go through. What would you guys want to hear about first?
I think like probably the best place to start for everybody is I think right at the beginning, because I think that's probably the part that both we, the host, and I guess whatever scientists are in the audience are unfamiliar with. But also I think that people who aren't scientists probably want to know that you're not just like gutting at like the old Dunder Mifflin office, or something like the office, and just like being like, "Yep," and so we're going to put the laser here, the hazardous waste there, no problem. Yep, yep. That used to be the break room, but that's perfectly safe for containing like, I don't know, a bunch of mutant rats or something.
I hate to say it, but the way we do things, you're not far off. Don't worry. It's a little bit better. We take the room apart first, and then we build something new in its place. Don't worry. We're not storing rats in the break room.
I think part of my questions there were also just along the lines of like, there's got to be rules for this, right?
Oh, there are so many rules. Yes. But I think first it might be good to get out of the way. So I work for a property management company, which is a little bit different than from an architecture firm, because we not only design what gets put in, but we also own it. So things are a little different. So we are what you would call, in the architecture world, I guess you call it a design build firm. Which is basically we design it and we build it, which is not necessarily what you do. Usually the architect and the contractor are two separate people. So what that does for us is that things are cheaper, things go faster, communication between us and the contractor is super easy. I can walk 50 feet from my cubicle to go down and like talk to the project manager, and he can do the same to me. It's really convenient. But also, for example, like we get our clients, like all of our clients come from, we have our own marketing team, we have our own management team, we have everything is done in-house for the most part. A lot of things. One thing that happens a lot with labs is that they are very specialized. No one lab is the same, which for us, we like to do things very standardized, which leads to us not being able to do certain things. So, if you want to put in, I'm just going to throw an example out there, a massive tank full of liquid nitrogen, we're going to have you find someone else to do that for you. We'll do almost everything else, but you got to find the guy who will put the tank outside. So that kind of starts what we do. So let's say, someone finds a client, they say, yeah, sure, we want to move in, we want to have a lab with you guys, and so we get started on designing it. So we'll go back and forth with the client and help them, figure out what they want, figure out what they're looking for. We'll go back and forth with them on that. And then...
So I guess I'd want to cut in here a little bit. So if you're a scientist, you've decided you've recently come into a massive pile of money, and you're like, I can make my own lab. I can do my own research.
Yeah.
What are the sorts of things that like you need to know going into this? Because I think that's like a question that I guess I wouldn't know how to answer. It's like, okay, so I want to start a lab and I want to, I don't know, make like a pharmaceutical company. I want to do R&D for making medication or something. What are the sorts of things I would need to know before I even start this conversation? You're gonna like the sort of thing that would be absurd for me not to know right now. Like I said, I'm nowhere near the position to do that. So, like, what were the sorts of the very basic stuff that you needs to start out with that you expect the client to know to begin with?
Yeah. So what they would need to know is what they're going to do. Like, is very helpful because that's kind of the basis for everything that the design is going to be. Equipment is helpful to know. Like, okay, what equipment are you going to be using? Are you going to have any need for future equipment? That sort of thing is always very helpful. But a lot of help happens. So a lot of people will have lab consultants, basically someone who is there to kind of guide them through the process. Because, they don't always really know what they need, which can sometimes be a little frustrating. but it's, that's what the consultant is there for, kind of help be the median and like help translate what we're saying to them and help translate what they're saying back to us. So it's very useful for that. So, if you can find a consultant, if you can afford a consultant, that's great. They're very helpful.
Sounds like
Cool.
it. I wouldn't even know where to start, so I feel like they're extremely
Yeah.
useful.
Yeah, honestly, like know what you're going to be doing, and that decides everything. That
makes sense.
Yeah.
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 Well, we like to say that form follows function.
And by like, when you say know what you're going to be doing, can that often be binned into like, biology labs kind of follow a similar like pattern to each other, or chemistry labs often like look similar to each other or something like that?
Yeah, they'll usually look fairly similar to each other. And like, for example, like, if you're doing, if you're still doing research versus if you're going to start prototyping process, those are two very different things, and look very different from each other.
So like
even
if
like
so if it's like, if I just want to like play, like, have a little academic lab where I exploring a lot of things, or if I want to like be in Sam's pharmaceutical company and I need to use like giant machines to pump out the product.
Right. Yeah. Well, a factory is very different, but let's say, we have a client who is working on building batteries. So they have this whole open space for, designing production lines to build their batteries. Versus, for example, we have a laboratory that just went in that is, going to be doing some of the more exploratory stuff. And, it's just a lot of like standard lab benches. They got a dark room, they've got a microscope room. Nothing terribly, specific. And that also depends on what you're going to be working with. If you're going to be working on, say, the common cold or E. coli versus, Ebola or the coronavirus, those are very different from each other.
Or mutant rats in the break room.
Yes.
I have a question, actually. It was speaking of old buildings. So,
go for it.
Ewan, do you find yourself like working on building new labs most of the time? Are you revamping old ones? Like, how does, like, I picture you guys like usually building the whole building from scratch, but I don't know like where your time falls versus like renovations versus like completely new buildings.
Yeah, so because we are a property management company first, we rarely build new buildings.
Oh.
We have about, maybe a project or two every year or so. And that depends on the process, because getting a building permitted is very difficult. We're working on one right now, and, the city has yet to, say yes to it. And it's been like a year. We've been beholden to local politics for a bit. And so, hopefully we can get that going soon. But also we're just like finishing up this massive complex that has taken us, I wasn't there when it started, so I want to say like at least a few years. It's taken them quite a long time to get it done. So maybe there's stuff in the future, maybe not. I'm not sure. And especially with the current lab boom here in New England, we are converting a lot of our office buildings into laboratories.
Oh, interesting.
Kind of piecemeal. So like, you'll have a lab, down the hall from, Joe Schmo's travel agency.
Hey.
But that's, that's kind of what we do. Like, we have all this space, and, we do, labs are hot right now. So that's what we're using. That's what we're just converting offices to labs. So that's what I meant by mutant rats in the break room.
All right. So let's imagine that my hypothetical pharmaceutical company, I know what I want. I want the mutant rats where the break room used to be. I want the, I want like some giant centrifuge, and like, I mean, just like some normal biolab stuff too. And so I've got all these things. I've got the list of things I want. I've got it all nice and orderly. Maybe I've got a consultant in there. I give you the list, and then what happens? How do we turn, the old, office space into a lab? What's the next step?
So once we agree to a design, we will, we will give you a plan, a set of specifications, which is basically, hey, here is a line item list of every single thing we are going to do to make this lab that you want, along with lease agreements, documents, things like that. You sign it all, you sign the lease, and then we get started on the permit drawings. So
what's on that line item list exactly? Is it going to be like, I want the giant centrifuge here, or is it going to be like more specific than that?
Yeah, I mean, so it is like, we're going to build a wall here. We are going to have an outlet right here for this machine, for your centrifuge. We will have, lights in this ceiling, and they're going to be this type of light. The paint will be this color, so on and so forth. That's what it's going to be.
Mm-hmm. Okay, so then you get started with the permitting, you're saying?
Yeah, so then we get started with the permitting. So we'll draw it up, say, hey, so we'll draw your outlet for your centrifuge on the plan, all of that. Once the permit drawings are ready to go, basically what the permit drawings are for are to show the town, hey, we're doing this, perfectly safe what we're doing. It's, up to all your standards. Everything's fine. We'll hand it off to them. Hopefully they say, yes, this is fine. You are okay to build this. And so we'll do that. And then we'll get building. Construction will begin.
So I guess one last question with the permitting. If I, for example, wanted a giant cutting laser and like potentially hazardous materials and a bunch of like things that like, does it ever come to the point where the town's like, I don't want that? Like,
so usually the town, so that will all get reviewed. And I know in a lot of towns there are forms that Sam's laboratory have to fill out saying, yes, I will have these things in my lab. I will be working with this stuff. And so the town will have to okay that in order for you to operate.
Mm-hmm.
So that's not a you problem, that's a me problem?
Yeah, it's a you problem. You don't handle that.
Okay. So I'd have to go fight the town myself when I say I want an Olympic-sized swimming pool full of sulfuric acid?
Yes.
that's not a...
For context, sulfuric acid is one of the most scalding caustic acids.
Oh yeah. And usually acids are a big problem because acids do raise a lot of concerns, especially with their disposal. Acid disposal is a toughie because there's a lot of paperwork with that.
Oh yeah.
You just bought yourself a lot more paperwork, Sam.
Okay, well, maybe I don't need the Olympic-sized swimming pool full of sulfuric acid. Cool. So, I guess we can probably get to this later when you talk about building stuff, but I'm sure you've probably dealt with a few strange things in terms of construction, right?
Oh yeah.
Tell us.
Oh,
the weirdest thing.
The weirdest thing you've had to build, yeah.
Things I've had to build, because I was going to talk about the lead-lined partition factory.
Oh yeah, no, talk about that.
So, actually, and this leads into another good project. So, we were going to build, it is a superconductor test facility. So, they were doing research on superconductors for energy transmission, and the space they were moving into had been used to construct these lead-lined partitions. So, say you're going to get an MRI or something, these are the walls you put in
Oh.
to, prevent your staff from getting all sorts of cancer.
Yay.
Wouldn't that be a CAT scan? X-rays.
Oh, yeah,
MRIs
it
are
would.
magnets, right?
That's right. That's a different. That's usually like a wire mesh. That's a wire mesh
Yeah.
partition.
It's less getting cancer, more getting thrown across the room.
Yeah.
just to clarify, for any of you who are going for like these sorts of medical procedures, people engineer these things such that first off, X-rays, you need to have a lot of them for them to be dangerous, and the MRIs just don't have anything metal in there.
Yeah. Actually, fun fact: I've seen plans of were they plans? No, wait. Never mind. Skip that. Never. I could have sworn, like, I can't remember if it was a dentist's office, and like that one panel like between the hallway and the dentist and like the exam room, that's lead lined often.
That makes a lot of sense.
Yeah, that makes sense.
You want to protect.
I don't remember if that's true. Don't quote me on it, because I remember. I think I one of the things I like to do is I like to do research on who I'm working with, just because I personally like working with context. Like, I like to know, oh, okay, this person does this, they are all this sort of thing. I like to know the why of why I'm doing something. I find that to be very useful.
Yeah.
But yeah, so unfortunately, they were not very careful with the use of their lead, so it was everywhere.
Oh.
It was in everything.
Oh no.
All over the building. It is. If I remember correctly, it had contaminated the entire building.
Yikes.
Yeah. So it had to be remediated. Like stripped down, torn apart, everything taken down and built from the ground up.
Dang.
Yeah. And so we wound up building this superconductor test facility on top of it. And the one interesting thing is that these superconductors were cooled with liquid nitrogen to help. I think it was to help with their conductivity. And so, what we had to do is they were very concerned about the liquid nitrogen leaking and evaporating. I don't know what people know about liquid nitrogen or just gaseous nitrogen in general, but I think nitrogen when compressed, isn't it like nitrogen when compressed into a regular tank is about like 1,000 times smaller, right? It's like compressed to 1,000 times, I've heard.
Smaller than,
I don't know.
Smaller than what? Like, smaller than it is as a gas.
So like versus like room ambient pressure.
It is really highly pressurized. That's like
Okay.
my knowledge, because it's like you have to like handle liquid nitrogen tanks carefully.
Yeah.
So
This is the non-scientist talking to all the scientists.
Yeah, well, the thing is, like, we just use nitrogen. We just get the tanks of it, and then we're just like, okay.
Yeah.
I don't know what the density of liquid nitrogen is versus the density of gaseous nitrogen.
not this is gaseous.
Oh, sorry, my
this is
bad.
gaseous nitrogen just in a tank.
Oh,
Well, I guess it just depends on how much you compress it then, right?
I would bet
Yeah.
that's like worse. Like, I bet that's more scary.
Yeah.
Is it?
I don't know.
So
I
yeah,
don't know.
basically,
None of us know that sort of thing.
Yeah. So
We're all biologists.
and honestly, liquid nitrogen is probably more compressed because once you compress it enough, it becomes liquid, right?
Oh yeah.
Isn't that
no,
how they do
yeah.
liquid oxygen
Yes.
in rockets?
No, wait, yep. Oh, wow, my PChem professor just got a headache.
PV equals NRT. Is that the thing?
Yeah. But I'm thinking about like a phase diagram, right? You have temperature,
Yeah.
and then you have pressure. So it's like one axis is temperature, the other is pressure, and like the bottom left-hand corner is solid, the upper right is gas, and then there's a bunch of lines in between that tell you
It's all.
there's something called a triple point where you get all three at once.
It's all coming back to me.
Yeah, I think in high school chem class.
Yeah.
You were in AP Chem.
We
with me,
were.
right?
I don't want to remember that class.
And our chem teacher put dry ice in a tube and like sealed it off. And when the pressure from the evaporating dry ice reached a certain point, you hit the triple point of it, and you had liquid carbon dioxide, solid carbon dioxide, and gaseous carbon dioxide all in one tube. Kinda cool.
I remember that. Yeah.
Yeah.
Wow, it's all
Yeah.
coming back. Yeah, I think
So-
I just think that liquid nitrogen is less scary, probably just because I work with it a lot, and I'm like, ooh, that's a cold boy. So
Oh,
Yeah, but like,
see,
you work with it enough. At first, it's like, oh, this is so cool, it's so dangerous. Now you're like, I took my hand. Liquid. Okay, maybe don't say that too loud. But yeah, you can write liquid
we
nitrogen.
do not, as a organization, we do not endorse any
I
of
tell my
these-
undergrads,
any of these
don't do
methods.
it. I'm doing it. Don't do it.
Don't
I'm crazy.
do
like me
because-
pouring it on the floor, like woo, like,
Oh
like,
my
like
God.
Fine. The pouring liquid nitrogen on the floor
Oh
is
my
fine.
god.
We do not endorse any
So
of
do you?
these
So wait,
methods.
so do you make the linoleum and they're able to? Is there like? Do you at least do some temperature tolerance, or am I like slowly destroying my floor every time I pour liquid nitrogen on it for funsies, Ewan?
Well, I don't know because the floor was a poured epoxy, so
okay.
probably a little resistant to any leakage.
okay, yeah.
Anyway, you had a great story that you derailed by asking us a science question that none of us knew the answer to. I think the answer is it's complicated.
It's complicated, it's dangerous, and if it leaks and turns into a gas, it will asphyxiate the entire room.
Oh yeah, that's the important part.
Yeah,
Yes.
that's pretty big.
That is scary.
The air-
Yeah, it
so the
will
air right
replace
now-
all the oxygen in the room.
Yeah. So just to clarify to everyone who's listening to this who doesn't know exactly what's happening there, because I think that's weird because you hear that the air is 70% nitrogen. The air should be 70% nitrogen, not 99% nitrogen.
Yes.
You need that oxygen in there, or you don't have oxygen, you can't breathe.
Yes. Yep.
Yeah.
Nope. It will kill
Yep.
you. So
just-
they were concerned about it killing you, and so they had to set up this very complex system to make sure they didn't, asphyxiate. So this system had two low oxygen sensors. It had the valve to let the liquid nitrogen in. It had a garage, basically just a big, big garage door, and a massive ventilation unit on the roof. So basically, you had to have four things be true. Basically, both low oxygen sensors could not be alarmed. The door had to be closed, and the ventilation had to be on. And so, if all those things were true, the valve would open. If something went wrong, the valve would shut again, and hopefully nothing goes wrong.
Yeah.
So yeah, I think that was one of the first big lab projects I worked on. That was, still one of the coolest, I think.
Yeah. Man.
So the build process in general, I think we haven't laid this out necessarily, but so what's going to go into the lab and you know where you're going to build it. So then what does that? You said in this case with the lead one, you had to do a bunch of demolition first. Is that usual? Do you usually have to rip everything down to the studs?
It depends. We like to reuse as much as we can. So we try to avoid ripping things down to the studs, but sometimes it's necessary. So yeah, you do your demolition, however much you need to do, and then you can start with then you put the studs back up. You start building the walls, at least you start framing it. And once you start framing it, you start doing all your electrical, you start doing your plumbing, you start doing your HVAC while everything is still open.
So HVAC being, just for people who aren't...
So HVAC is heating, ventilation, and air conditioning. So HVAC. HVAC.
Okay, so that's what's going wrong when I walk into lab and it's like 50 degrees.
Yes. Although that also might mean it's working with a lab. If it's colder, it might be working. Maybe. Because I can get into that right now. If you guys want, I can talk about HVAC if you guys want.
Yeah, I think that's kind of an important part of the lab.
Oh, it's very.
Yeah, there's definitely a lot of other things that I certainly want to get to. Like, I think it'd be cool to also chat a little bit about some of the things you have to consider with specialized things that you're building, like maybe, for example, animal facilities or clean rooms, as we mentioned before. So thinking about that would be cool too. But let's talk about this first. I'm curious.
Actually, I could kind of use that. I mean, I could talk about animal rooms and stuff as a segue. Because a lot of the specialized stuff we won't do, just because it is just that specialized. We have done some vivariums, which is your animal rooms. We've done a couple of those, but we don't do too many. And those do require their own special HVAC. Animals need a lot of help to be kept alive, surprisingly. And so with HVAC in a lab, all our labs are designed for 8 air changes an hour. Basically, if you have a room full of air, all that room is taken out and replaced 8 times an hour. Which is why it might feel a little cold, because especially in the winter, you're just taking, cold air, heating it up a bit, and then just dumping it into the room.
So, how does that compare to like an office?
So an office uses a recirculating system. So we design our systems to use about 15% outside air. So the air change is, I haven't really ever measured the air change per hour, but it's a lot lower. So we'll take the air, freshen it up, reheat it, add some fresh air from outside in, and then put it back into the office.
Okay, and so that explains like why, like with COVID and everything, they were talking about like putting HEPA filters into things and everything. So that's just that's just purifying the recirculated air.
Yeah, because you're just breathing the same air every day. Not the same air every day, but
But there's a good reason for that, right? Because it keeps it from wasting all that heat, right? I imagine.
Oh yeah, those systems are a lot more efficient when it comes to heating. Because instead of having to do you've got like 20-degree air and you all of a sudden you have to heat it up to 68. That's a huge change. That's massive.
Okay. Yeah, that makes sense. So cool. So like with an animal room, is that still the 8 air changes an hour, or like how does that?
I'm not quite sure how many air changes per hour we need for that. But one of the interesting things with an animal room is that is a closed system. So basically, it has its own unit for taking air in and its own unit for taking air out. Those units, the air will also be done for humidity. So you have to make sure it's the correct humidity, have to make sure it's at the correct temperature. If the power goes out, it has to be wired to a generator in order for it to keep functioning. You usually also need them in duplicate in case one has to go down for maintenance. Like that has to be running 24/7 in order to keep animals at a comfortable temperature.
Yeah. We I don't know. Oh, it's probably public record, but I know it must be public record. But I have one of the schools I have studied at had a failure of both of those systems. It was ugly. A lot of animals died. The feds were involved. It was bad.
Oh no,
that's
because
unfortunate.
It was like in the middle of the summer, and the whole ventilation system failed.
Yeah,
that's what you're trying to avoid. Schools and maintenance. I've heard people complain that academic institutions have what someone kind of luridly referred to as an edifice complex. They keep building buildings and they don't bother maintaining them.
I know that feeling.
That's pretty punny.
See, it's the opposite. We don't build anything; we just maintain it all. It's great.
Yeah.
No, but what you're saying definitely makes sense, because like I've never really thought that animals like needed like specific humidity or like special air, but it turns out they do. Like I'm trying to think of like an animal room might look different for like people that work with mice, people that work with frogs, people that work with fish, so there's definitely a lot.
Could be. I have no idea what a fish room looks like. I I have no idea.
Sounds fishy to me.
Sounds fishy.
Sounds fishy.
There's just a lot of fish.
I have a fish tank. I just upgraded it this weekend.
Ooh.
It's a lot of plumbing. I imagine.
I
More
imagine.
plumbing if you do it professionally.
Another.
I have a little 10-gallon fish tank that I overplumbed. The fish are very happy. They're liking their excessive filter system.
There's another design challenge for you, Ewan. Design the fish room where all the fish
Design
reside.
a fish room. Ooh, I've always wanted to design a fish tank. That'd be fun.
Maybe one day.
That makes
So-
sense. Yeah.
So all of this stuff, I also am curious about like the timeline of all these things. So when you get in there, you get the permitting, you get the construction. So the lab I've been working in, there's like on my floor they've been putting another lab, and it's been like all summer. It's just been like sawing, hammering. They broke down walls. Then they started putting up new framing, and they did all this stuff. And it's after they had all the conversations with the new researchers coming in there. Like, is that normal for it to take like, I don't know, probably, few like four or so months to do all the permitting, and then I actually did see a lot of that, and then like kind of a lot of time with the construction, and then there's like some weird revisions they have to do. I guess there's also someone walking around with a stack of blueprints for a long time, like trying to figure out.
Me. I'm that guy.
You're that guy. Okay, yeah.
Well, I'm the guy who walks around with all the blueprints, not necessarily,
Yeah. So like, what's the timeline usually look like for you all?
So the timeline, so from sort of idea to signing a lease, from my experience, it takes anywhere from like 2 to 3 months. And then the actual permit takes anywhere from a few days to a month, depending on the town. And then construction, right now we have we usually say, hey, we'll get this done in about 5 or 6 months is usually how long it takes.
That's quick.
Yeah, I thought it was longer.
Well, most stuff is art, and sometimes it's shorter than that. It really depends on the complexity, what we are starting with. So, hey, is the lab already there? Perfect. It's going to take us a lot less time. It can vary. And we have a lot of equipment that has some very long lead times. So basically, how long it takes for us to order it and then get shipped to our door. So lead time on some of this stuff will take 6 months. That's the last thing to go in. Like generators, for example, we just have some in stock so that they're ready to go when we need them.
Cool. I think in terms of like equipment, I think one thing that speaking of also the fish tanks, like is there like, so you talk about the plumbing like for like a lab, because again I'm kind of in plumbing mode after this weekend. Is there like anything really interesting that happens with that, like in terms of like, because I'm imagining electrical is electrical, right? I mean, there's probably some like heavy duty electrical stuff for some heavy duty equipment, but
oh yeah, there is.
Is that like a big retrofitting process probably for that too?
Electrical?
Yeah.
Very quickly, it can be. Usually labs require more power than an office does, just because a lot of the like the HVAC is an energy hog. You've got a lot more equipment running all of a sudden. That also takes a lot more power. So yeah, sometimes we have to upgrade the amount of power going into the suite.
Yeah.
One of my favorite things about working in a lab though is when you can get like deionized water like on a plumbing system. Like when I can just like turn a tap and I can get just straight up water. So like for those of you who aren't scientists or don't like, I don't know, think a lot about water, the stuff that comes out of the tap has got a bunch of stuff dissolved in it. It's like it's got chlorine to treat it, so the stuff isn't growing in it. It's got fluoride in it for your teeth usually. It's got anything that's dissolved in it, and like you need stuff dissolved in your water. We as humans aren't used to drinking just straight up water. But in a lab, you don't want all those things. You want just pure H2O. And so it's great in a lab to just have a tap you turn on and it just comes out. But like, and also like, again, I guess it's probably, I imagine maybe you can't trust us to pour things down the sink that is just water either. So like, kind of, what does that process look like to make it so that you go from like plumbing that's, tap water and, a drain to, can put out pure water and, get rid of, tolerate a couple of brain farts maybe on the part of a scientist, or even just like buffer solutions that are just weird. Things that can go down a drain that are still strange.
Oh yeah, DI water we don't even have. We don't touch that. Like if you're moving DI water, we don't touch it. And the city doesn't want to touch it because the fun thing is, most of your pipes are made out of steel, iron, whatever. Hopefully not lead anymore.
I was just thinking, I was like, oh
no. Yeah, hopefully not. But at least at this point, it's sewer water, so the fish will deal with it. Sorry, fish.
That's what. So there's still like lead sewer pipes out there.
There could be. There very well could be. Heck, you hear about New York digging up wooden pipes.
Yeah.
Like, what's up with that? But the issue with deionized water is because, there's none of that, extra fun stuff in there. All of a sudden, that water is going to want to get all of that back. So it will just corrode your pipes. It will just eat at your pipes and, take all that lovely pipe material and put it into the water, which eats at your pipes, and all of a sudden you got a leak of deionized water coming out. But with things like acid and any other sorts of, wastes that are, not like incredibly hazardous, what the MWRA, which, we work in Massachusetts, so that is the Massachusetts Water Resource Authority. Do I have that right?
I googled it when we looked it up when we talked about this in our prep, but I can check that quick.
Sounds right.
I want to say it's the authority, or it's either the authority or the administration.
Authority.
That's the authority. Authority sounds better. And so basically, their rules are: you can't just dump straight acid into our pipes.
I feel like that's
because once again, it's acidic. It's gonna eat everything up, and all of a sudden, you got a hole in your pipe that is now leaking acid. So what labs are required to do is, if they're going to be pouring acid down a sink, what we will install is what's called a acid neutralization tank. There are a few other ways to describe it, but that's what it's called. And that tank it's a 5-gallon bucket, typically 5-gallon bucket for your average sink, maybe bigger depending on how much water goes into it on a daily basis. And that tank is full of a basic material. Usually it's like limestone, granite, something like that, something like basic, but also generally cheap to find. And that will, in theory, neutralize the acid and take care of any problems that the MWRA has.
Oh, cool.
Yeah.
And just to clarify, since I'm sure the MWRA is actually listening to this, you don't have to worry about this, but as the token scientist working in Massachusetts on this call, you're not supposed to put acid down the drain to begin with, but if somehow it accidentally ends up there, you also want probably that protection between you and the outside world, and so that's what that tank is probably for. Always, if you have a severely acidic solution or something, you just store it and have a hazardous waste company deal with it.
Yep.
You put it in a bottle, you put a tag on it, and then that tag is essentially there to have someone take it and have it be not your problem anymore.
Yep, it's put in a nice little like fireproof room that you don't have and you don't have to deal with. Like, we have those. We'll design those. We've got little fireproof rooms to store your waste in.
Oh, that's cool. I didn't know that either.
Yeah.
Wow.
Well, not fireproof, but fire resistant. Not fireproof.
What's the difference?
So what we do, the walls, I believe, are supposed to be what is 2-hour rated. So 2-hour rated means it will take 2 hours to burn through the wall. And generally that's an accepted amount of time. By that point, the fire department will have arrived, hopefully taken care of the fire. And so, the flames won't get into your room full of, hazardous waste and cause problems.
Cool. That's good.
That is
Am I
good.
the one who's had to deal with burning acid before?
Probably.
Wait, what?
So,
no.
fun fact, super
Fun
glue
fact.
burns and releases acidic smoke. I learned this on a science fair project in high school where I was cutting through some pieces of wood I'd glued together with super glue, and I was running the drill too slow because I was being nervous about it, and I made a cloud of black burning smoke.
Oh no.
Super glue is really nasty stuff if you use it in any way other than intended. It turns into cyanoacrylic acid, which
That's
is
terrifying.
acrylic, which is, I guess, whatever like an acrylic base is with a cyanide group that can give up hydrogen atoms to your eyeballs.
Oh no.
It's not fun. It was miserable.
No, were you okay?
I was fine.
Okay.
The solution was to just turn up the drill. But I hadn't anticipated that just drilling through a couple pieces of wood would make a cloud of acidic smoke. It's not fun. And that's not a particularly strong acid as far as I can tell. It's just unpleasant.
Yeah.
Our listeners, please avoid drilling slowly through superglued pieces of wood. We do not condone this.
Oh, I don't condone it either.
Would not
When
recommend.
storing any flammables, put them in a metal container. You can find metal cabinets on like Home Depot or like Uline or whatever. Like you can find them.
Yeah, all right.
Yeah.
So, speaking of things people should know,
Yes.
so I guess, what, in terms of like every scientist or anyone who's ever worked in a lab, is there anything you want us to know, just kind of basically about labs, just kind of as a takeaway?
Yeah, so I know that in a lot of labs, especially the bit larger ones, you will have some sort of lab manager, basically someone who takes care of the lab, sort of runs. Basically, it's like an IT guy for your lab.
Yeah.
He's the person who will make sure everything's working for you. But even still, like, as a scientist, it should be very easy for you to be curious. Always be curious, like, how do things work? Even like in your everyday life, how does your refrigerator work? Because that is a magical box full of thermodynamics, my friend. I still don't but how does it do that? Like, I still don't quite understand it.
PV equals nRT. We already said that equation before.
It takes.
That's how
I know, but
refrigerator
how
works.
does the hot become the cold? And
It
how
takes
does
the
that work?
heat and pushes it somewhere else.
I know it does.
Why don't we
but
take the
where
heat
is it?
and push it somewhere else?
I can explain how a refrigerator works, but we could also essentially it uses, so PV equals nRT is the equation for what we call the ideal gas law. It's that pressure times volume equals the number of molecules times a constant called R times the temperature. And so if you can't change the number of molecules too easily without like venting something, but you can change pressure and volume, and you can then use that to change temperature. And so the way an air compressor works, the way that a refrigerator works is you have a liquid, and it evaporates on contact with heat. In this case, it's actually the cold inside of whatever you're trying to cool. And then that warmer liquid comes out, goes through a compressor, which then actually has like a fan blowing across like all the tubing. So what it does is it compresses things, so the pressure goes up, and then the excess temperature is just blown off. And then you have this cold stuff that then goes through and it evaporates. It's actually not exactly PV equals nRT because it's an evaporation and condensation cycle. So condensed stuff evaporates. Evaporating takes in heat. Then you condense it again. The heat gets blown back into the environment, which is why the back of your refrigerator is really warm. And then wash, rinse, repeat. You just pump heat out. You can also run it reverse to make a heater.
Yeah, see, I thought it was liquid the whole time. I thought it was like liquid the whole way through. So I was like, how does that work?
I think there's also different designs too, but yeah, it's usually a temperature that's like usually a substance that evaporates close to whatever temperature you're trying to work with, which is why most refrigerants are nasty, because it's just a very specific temperature range, and you just need something that does that. You might know this, but lab refrigerators have recently become explosive.
Oh yeah, because they can't use Freon anymore. So like,
Well, it's not that. Well, yeah, they can't use Freon, but there's like they changed the classifications of refrigerants, so now you can use propane as a refrigerant because it works as one. And so,
yay!
I actually don't know if it's actually compressed the same way, but a lot of lab refrigerators these days use like propane or ethane or something, and so it's just running with natural gas. And so if you get a leak, it can explode.
Cool.
It's happened a couple times. It catch on fire in the lab. It's fun.
Cool.
Nice.
Yeah,
Good to
especially
know.
when like people are using like Bunsen burners and like strikers in the lab, like flames everywhere. Like,
Household refrigerators aren't allowed to use
and
laser refrigerators.
this is
Okay.
why safety and constant checks about the health of your equipment are important.
Yeah, it's also about
usually
being
we
curious,
will
right?
put all our freezers in one room.
Yeah, that too.
Yeah, so this is going back to the being curious, like you were saying. Sometimes, in my experience, that can lead you to some very interesting bits of information.
Yeah, no, you just like learn all this cool stuff, and like I just find it's useful, and I'm a big like I don't know if I should say this, but like I'm a big right to repair guy. Like you should know how to like fix stuff, like know how to do your own oil change. It's not that hard.
It's fun.
It is fun. I know exactly. It's great.
I don't think this has been said, but you and I have been friends for a very long time,
We've
and
been friends for a very long time.
we have been involved in repairing all kinds of things at this point.
Oh yes,
We've worked on a diesel locomotive once.
we have. That was fun.
Anyway.
But yeah, no, just like be curious. It's great to know things, and it always helps to know how to talk shop with someone. Like that is halfway to anywhere, knowing how to talk shop.
I gotta say, like, I had an experience at my lab that I was working at before I went to medical school, and we had tons of issues with our freezer. Something was wrong with the compressor in the freezer, and so I had to talk shop with the guy who was involved in the maintenance and stuff, and I picked up a lot there, and it was absolutely invaluable for making sure our materials, like our tumor samples from like a very long time ago, or like the very special like gene edited cells that someone had made that were like their prized possession. Like it all came in very. Everything that I learned from this guy came into play when we had like a emergency where our freezer stopped working, and like yeah, it's talking shop, like knowing how your equipment works is absolutely invaluable for us scientists, and we don't do it enough.
Talk shop.
Talk shop. Learn how to do it.
Yeah, man.
Is there anything else you want scientists to take away, Ewan?
That's my big takeaway. that's like the big one.
If there is one thing,
take that away.
take this.
There's one thing. Take that.
Be curious.
Yeah, I think for me the really big thing about all of this, and part of why we were really wanted to make this episode where we're talking to someone who actually isn't a scientist by trade, is that kind of take home the message that scientists can't science alone. We can't
Sure
do these
can't.
Yeah, we can't do these things alone, and we in order for like scientists to do work and discover new stuff, we need to be able to turn on the lights or turn on a centrifuge, or not suffocate on our tanks of nitrogen gas or whatever it is. And it's not, at the end of the day, the people who make that happen are people like Ewan, who actually build labs, figure out how to make all these things work,
and make them safe also.
Yeah.
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 And so it's super important to recognize that like scientific advancements don't happen on an island. They're not just the person who's mixing stuff in test tubes and writing papers, but it's also the people who put the lab together and make sure it still functions. And it's something that I think that I feel like is underappreciated in science. That in all these discussions, that like all the stuff that we use and everything that we do happens because someone put it there. Labs don't grow on trees. Thanks for building these labs and making sure that these labs come into existence and are safe and are functional. And coming on and talking to us for about an hour now to kind of explain how all that happens. And for everyone out there who, scientists, non-scientists, people who are helping scientists do their jobs, we'd love to hear from you. We have all kinds of social media. So we're on Twitter at the Interactome, Instagram at Interactome_media. And we're on YouTube where we post a lot of these episodes as audio. And of course, if you're listening to this not on YouTube, we are on most major podcast platforms. And if you ever want to reach out to us on any social media or leave us a review anywhere, we'd love to hear from you. And if you have any more stories about science adjacent stuff, or just maybe even just want to ask people like Ewan questions, we'd be glad to hear from you. We'll forward them, or I'll just add him on social media.
Shoot me a text message, Sam. Don't shoot me a text message. Go through them. I'm very shy.
Yeah, I'll figure it out. I'll hop on somewhere and ask him. I mean, and if there's anything anyone wants to hear about, we'd love to hear from everyone. We'd love to hear any ideas anyone has, and who we should have on next, and what we should talk about next. Thank you for listening, and again, thank you, Ewan, for joining in.
Great to be here.
Woo! Thank you, Ewan. Woo!